In this chapter, we're going to look at rational expressions. In this lesson, we're going to look at solving rational equations.
All right. Hi, everybody. So in this lesson here, we are going to be looking at solving rational equations. Okay. So here we go. Here's a little bit of a kind of a breakdown as to how you might approach these things. First of all, we want to factor all denominators. Now, we might actually do more than that. You might also want to factor all numerators. And the reason you might want to do that is to simplify expressions if you can. Okay, so simplify expressions. Now, we're going to see in a couple of the questions that we're about to do here that there will be a couple of situations here where there's two different methods that we can or two different paths should say that we can follow. One is longer than the other. Okay, and we want to take the shortest path to the answer as often as we can. We're going to state the non-permissible values. We got to do that. Okay, that's a really important step here because that helps us evaluate the solutions that we get at the end as to whether they make sense or not. Then what we're going to do is we're going to multiply each term, and we cannot emphasize that word each. In fact, I'm going to highlight that there. We're going to multiply each term by the lowest common denominator. So after we factored all the denominators, which is really what that first step was about here, was about figuring out what the denominators are, the factors are, so I can create the lowest common denominator. We multiply that through, and then we reduce or we simplify each term, and then solve for x. And if the answer is a non-permissible value, then that's an extraneous root. Okay, it's a root that pops up once we convert the rational into a polynomial, but it doesn't satisfy the original rational. Okay, it might work in the polynomial that we created, but not in the rational that we started with. So you have to reject that root. Now, this is just a kind of a side note here. If it's a single term on each side, then we can cross multiply. Basically, if it's a proportion, then you can cross multiply to solve that. Okay, in any case, with that all being said here, the easiest thing to do here, or the best thing we could do here, as I should say, is just to do some questions. Okay, so let's jump right in here. We're going to solve for x for each one of these. So we take a look at this first equation here, this 5 over x plus 2 over 3 equals 4. And I know my first step is to factor here, but there's really nothing to factor. I do, however, have a factor of x in the denominator and a factor of 3 here. So I'm going to multiply everything through here by 3x. Okay? Now, that's the first thing I'm going to do, and I'm going to put a little comma over here because I'm going to do this off to the side here. I want to recognize here that because of that first term, x can't be equal to 0. So right off the bat, I just want to recognize that that is going to be a restriction here. Now, when I multiply that through, that 3x, what we're going to get here is we're going to get 15x over x plus 6x over 3 equals 12x. Okay, that's when I distribute that 3x through to every term there. Now, and I'm multiplying every numerator by that 3x. X can't equal 0 again. That's going to stay there. Now, I can simplify because I've got this x divided by an x, and I can do that so long as I don't let x go to 0, and that's a restriction that's stated over here, so that's great. 6x divided by 3 is going to be 2x. And then on the right-hand side, well, nothing much happens. It's going to stay 12x. And again, this is all with the understanding that x cannot equal to 0. That restriction still stays there. Now I'm going to bring that 2x over. Okay, I'm going to subtract that from both sides here, and that's going to get me 10x on the right-hand side with a 15 here. So again, I subtracted 2x from both sides to get the x on one side. And now I'm going to divide. Okay, and I'm going to divide both sides by 10. So sorry, I should have stated up here, x can't be equal to 0. And then when I divide both sides by 10, I'm going to get 15 divided by 10 on the left, which is going to reduce to 3 over 2. And notice that 3 over 2 isn't 0. Okay, it's not equal to 0, so that's my answer. X is equal to 3/2. So for this next question, B, we've got 3x plus 2 over x minus 5 is equal to 4 over 5. Now, here's a case here where we've actually got a proportion. Now, before I do anything, I should look at this and see if I can factor anything, but 3x plus 2 won't factor, x minus 5 won't factor, okay? So that actually isn't going to work here. So I will identify that my x value here cannot be equal to 5, because if it is, I get a division by 0 on the left. So don't want that to happen, but that's the only one. And now what I'm going to do here, because it's a proportion, I am going to do what we call cross multiplication. So I'm going to get 5 multiplied by 3x plus 2 will equal 4 multiplied by x minus 5. And then I'm going to get 15x plus 10 when you distribute that through, plus 4x minus 20 when you distribute the 4 through. Now, and bear in mind that this is still x can't equal 5, x cannot equal 5. That restriction kind of exists all the way down here. Now, okay, do you have to write it every time? Well, quite honestly, you're gonna have to figure that out and see what your teacher's expecting, okay? Some teachers don't care as long as you've mentioned it once and you're using it at the end to evaluate, they're fine with it. Other teachers aren't gonna be quite that easygoing with that. So you're gonna have to kind of just feel out what your instructor is expecting at that point, okay? So now we're going to bring the 4x over. I'm going to subtract 4x from both sides. Actually, I'm going to subtract 10 from, whoops, sorry, I'm going to subtract 10 from both sides as well. Get rid of that there. Sorry, I wanted that to be subtract 10. And so 15 minus 4 will be 11x. Negative 20 minus 10, that's going to be negative 30. Again, with a stipulation that x can't equal to 5. Now I'm going to divide both sides by 11, and I'll get negative 30 over 11. And that isn't equal to 5. So there we go. My solution here is x is equal to negative 30 over 11. So for this problem right here, again, our first step is going to be to factor, but none of those terms here, none of the numerators or denominators look like they need any more factoring. So I'm going to be looking for the lowest common denominator, and I see an x here and an x minus 1 there. So my lowest common denominator is going to be the product of those two. Bear in mind here that the subtraction that we're seeing here basically keeps that together. The bar for division kind of implies a set of parentheses around that, and so that x minus 1 becomes one term here. It's sometimes an easy mistake to make is to think that there's an x here, I see an x here, and I see an x here, and to treat it as if that just means that there's this common x. Okay, so when we say common, we don't mean that you're seeing a lot of it. Okay, we mean shared, and the factor here, in this case here, the factor is x, but in this case, the factor is that binomial x minus 1. But what I'm going to do here is I'm going to multiply numerator denominator here by that common denominator, the product of the two. Okay, there really is no shortcut right there because x and x minus 1 will be different. And so their lowest common denominator is actually just going to be the product of those two. And you've probably done that before when you've kind of added and subtracted fractions. You just multiply the denominators together. Well, yeah, frequently that's how we'll do things. So in this case here, our non-permissibly, well, x cannot equal, first of all, because of that first term, x can't be equal to 0. And because of the second term, x can't be equal to 1. So there's those two restrictions there. Now, if we multiply through by that x minus 1, we get 3x, x minus 1, and this is all over x. Okay, so we just multiply the numerator, then 5x times x minus 1 over x minus 1 is equal to 5x times x minus 1. And again, we got to state here that x can't be 0 or 1. Now, I'm going to do this probably another time here, and then we're going to take a bit of a shortcut with this, because notice that the x's cancel there, the x minus 1's cancel here. Notice that my denominators basically all disappear, and you know what? That is always going to happen. If I multiply the numerators by the lowest common denominator, that's going to happen. I'm always going to get rid of those denominators here. And I do that on purpose so that what I'm left with here, when I multiply that 3 through, will be 3x minus 3 plus 5x squared. And this is going to equal 5x squared minus 5x and again where x cannot equal 0 or 1. So all of a sudden now I've got this polynomial, and I'm actually quite happy with that. I don't mind working with the polynomial. That's not, I've had a lot of experience with that. We're good. I notice that I can subtract 5x squared from both sides. And then maybe what I do here is I'm going to add 5x to both sides and maybe add 3 to both sides to move those terms around. And what that gets me is 8x on the left. And because on the left-hand side here, the 3's will cancel, well, that'll leave me with a 3, just a single factor of, value of 3 on the right. I'll divide both sides by 8. First, I'm going to state the non-permissible. And then I get that x must equal 3 over 8, 3 divided by 8. Well, that isn't 0 or 1, so we're good. That's the answer. X is equal to 3 over 8. All right, for this question, once again, I look at it and I'm looking for something to factor first. And it really doesn't look like there's much to factor. My lowest common denominator, though, when I take a look at this, I know I've got to have at least an x squared in it. In these two factors right here, okay, I've got single factors of x. So I know that having an x show up is important, but I got 2 of them here in this denominator on the left-hand side here. So my lowest common denominator here must have at minimum those 2 x's. Then I just got to look at the 15 and the 5. And actually, it turns out I will include a 15 there. Okay, because 15, does 15 include a 5? Yep, it also includes a 3. So I need there to be a factor of 3 and a factor of 5 in there. So there's 15. Now, what's my non-permissible? Well, in each of these cases, it's just the monomial denominator. Okay, there's no addition, there's no subtraction, and so we are going to get that x cannot equal 0. Okay, and so that's what happened. We saw that in the very first question here, but it's even more of an issue now because there are these products that we're seeing in the denominator here. But if x shows up as a factor all by itself, okay, then the restriction will be that x can't be 0 if it's a factor in the denominator. Okay, so now we get x minus 3 multiplied by, and I'm going to put that in an order that looks better, 15x squared over x squared will equal 11 multiplied by 15x squared over 15x minus 2 times 15x squared over 5x, where x cannot equal 0. And now, and we're going to do this one more time here. We're going to do the canceling here. 15, 15. One of the factors of x is going to cancel. I still had another one in the numerator, so there's still an x up there. And then here, the 15 divided by 5, that's going to leave us with a 3. And then again, we're also canceling out a single factor of x there. So putting that together, on the left-hand side, I've got 15 multiplied by x minus 3, so 15x minus 45. Here I am going to get, what is this? It's just going to be 11x, looks like, minus 6. Okay, under the stipulation that x cannot be equal to 0. All right, well now, what I'm going to do is I'm going to bring the x terms to the left-hand side. So I'm going to subtract 11x from both sides. And I'm going to bring the constants to the other side. So I'm going to add 45 to both sides. So now, oh, I'm sorry. You know what? I just realized something, kind of looking at my work there, and somebody might have been screaming that out there that I did make a mistake here. Okay, so what I did, and actually, I'm going to erase. I don't really need to erase much. I just need to fit this in here. You know what? If actually, this is not a bad opportunity. If you caught what I did wrong, that's awesome. Just keep going here. But if you missed what I did wrong, if you didn't see the error that I made, maybe just pause the video right now and have a look at the question and see if you can catch what I did. So now I'm going to just go through and I'm going to plug it in here. What happened was in that last term, I forgot that there was 2 factors of x in the numerator, and I only canceled 1. So that should have left me with a 6x there. So, and actually what I'll do is I'll take a moment and just clean this up. Okay, I'm just going to clean this up. Whoops. Clean this up for right now. Oh, Sorry, my computer is having a hard time. It is, there we go. I'm going to clean this up just a little bit first before I go on. Okay, so we're going to get 15x minus 40, whoops, minus 45 is what I wanted to write there. Minus 45 is equal to, that's going to be 5x, where x can't be equal to 0. So now what I'm going to do is I'm going to subtract 5x from both sides, and I'm going to add 45 to both sides to get me 10x is going to equal 45. And so when I do, and sorry, with the stipulation that x can't be equal to 0, and when I divide both sides by 10, I get 45 over 10, which simplifies down to 9 over 2. And 9 over 2 is not 0. So that's good. That's fine. That is the answer that we're looking for. All right. So for this question here, finally, we got a little bit of work to do to factor this first. On that first term there on the left-hand side, I can factor out the common x. And then actually, that's about all we can do. Whoops. Not equal to, that's going to be subtract. Subtract 5 over x here. Now, I am going to end up multiplying by the least common denominator there. Now, I notice that I've got a factor of x that shows up in a couple. I've got a factor of x minus 3 that shows up in a couple. So that means that my lowest common denominator here is going to be x multiplied by x minus 3. It's going to be an expression that has every factor that shows up represented. Okay, I should be able to see every denominator in the lowest common denominator. Like I should be able to see all of the different pieces there. And I'm going to multiply that with the understanding that x cannot equal 0 or 3. Now, I already know that when I do this, when I multiply through by that common denominator, things are going to cancel. So for example, on the left-hand side, because the denominator is exactly the same as the lowest common denominator that I'm multiplying through by, they're going to entirely cancel. So I'm just going to be left with the numerator. With the 6 over x minus 3, the x minus 3 will cancel, and I'm just going to be left with that x up in the numerator. And then with the 5 over x, the x is going to cancel, and I'm going to be left with that x minus 3 factor in the numerator. And so we can take just a little bit of a shortcut there without writing those terms and then canceling. We can set it up like this. So now what I will do is I will expand, okay, out. I will multiply that negative 5 through. Again, x can't equal 0 or 3. And then I'm going to put those terms together. So I'm going to get 6x minus 5x is just going to be x. Okay, plus 15, where again, x cannot equal 0 or 3. And then I'm going to subtract the 15 from both sides, and I'm going to get 3 is equal to x. Now, in all of the previous questions that I've done, once I got to this point here, I didn't write the restriction anymore because the restriction didn't have any impact. Ooh, but now it does. So I'm getting an answer of 3. But x cannot be equal to 0 or 3. So therefore, those 3 dots there mean therefore, okay, there is no solution. And you need to know that that's a possibility, okay? Because I get it. If you're working through this on an exam and you get a question that has no solution, the first thought that goes through your head is probably not, well, there you go. There's no solution. It's probably, oh shoot, I did this wrong. And you go back and you try to figure out where your mistake is. But you need to know that it is a possibility that that equation simply doesn't have a solution. Now for this question right here, for F, first of all, I'm going to look for factoring, but there is none. Then what I'm going to do is I'm going to look for the lowest common denominator. And in this case, it's actually going to be just that simple little x minus 2. There is no other denominator. That actually works out really, really nicely here. So, and that's going to be in the situation here where x is not equal to 2. So now when I multiply that through, on the left-hand side here, I've got the two terms. I've got the 4x plus 3 over x minus 2 and the plus 6. When I multiply that by that first term, the denominators will cancel. All I'm going to be left with is 4x plus 3. then because 6 is only over 1, there is nothing to cancel here. I'm going to multiply that numerator by x minus 2, and there's nothing to cancel, so it stays like that. Whereas on the right-hand side, again, the x minus 2 is going to cancel, and numerator and denominator will be left with 11. And again, that's still with the understanding that x cannot be equal to 2. But now it's just a little polynomial thing here, and it's actually a nice little linear. So 6x minus 12 is 11. Again, x can't be allowed to equal to 2. So what do I get here when I put together the like terms? I'm going to get 10x minus 9 is equal to 11, where x is not equal to 2. So now I bring the 9 over, so 10x is going to equal 20. Oh, and here we go. We're going to get a problem. So x can't equal 2, and then I get that x is equal to 2, but x can't equal 2. So therefore, there is no solution. And again, that's okay. All right, so now for G here, we do have the opportunity again. We do a little bit of factoring. So here we go. So 2x over x plus 3. Okay, well, not much is going on there. Neither is there anything with x over x minus 3. But the denominator on the on the right-hand side is a difference of squares. So I can break that down into x plus 3, x minus 3. And now when I look, I can tell, okay, that, I mean, I've got really just two factors showing up in the denominators. I've got an x plus 3 and an x minus 3. Every time they show up, they only show up once. And so my common denominator is simply going to be the product of the two, with the stipulation here that x cannot equal plus or minus 3 in this case because of those two terms there. Now, so we're going to speed up through this just a little bit here, because when I multiply that through in this first term, the x plus 3 will cancel, and I'll be left with x minus 3. In the second term, the x minus 3 will cancel, and you'll be left with x plus 3. And on the right-hand side, both of those factors are going to cancel, and you're just left with 18. Again, with the understanding that x cannot equal plus or minus 3. And again, I'll say it like this. Do I need to keep writing that x can't equal plus or minus 3? Again, it really depends on your instructor, how your instructor wants you to write that, okay? So you have to pay very close attention. So here, when I expand that out, I'll get 2x squared minus 6x plus x squared plus 3x is equal to 18. X can't equal plus or minus 3. Now, I clearly have a quadratic here, so I'm going to group together like terms, and I'm going to bring the 18 over. So I'm going to get 3x squared. Looks like minus 3x minus 18 is equal to 0. X can't equal plus or minus 3. Now, I like what I'm seeing here. I've got a common factor of 3. So I'm actually going to divide everything through by 3. And I can do that as long as you do it to both sides of the equation. And when I do that, the 3's will cancel. So I'll get x squared minus x minus 6 is equal to 0. And again, x still cannot equal plus or minus 3. And now we've got something that's a little bit more challenging. Okay, I've got to factor this. So I'm looking for two factors of negative 6 that are going to add to negative 1. And that's going to be negative 3 and positive 2. And so as a result, and hopefully you're comfortable with this, x is going to equal 3. X is going to equal negative 2. But x cannot equal plus or minus 3. So what that means then is that that first root is no good. It's an extraneous root. But the second root is okay. And so negative 2 works. Negative 2 is okay. Okay, so for the last one that we're going to look at in this little section right here, there's nothing really to factor. Okay, there are no little binomials here or anything kind of multiplied through to factor. So when I look at my denominators here, I've got an x plus 2, and remember that holds together as one thing, one factor. And I got a 6. So my lowest common denominator here has actually got to have all of those represented. Now, the non-permissibles that'll go with that is like, well, I can't let x go to 0, because if it does, the first term is undefined. Can't let it go to negative 2, or that second term is undefined. And so those are going to stick with me the whole way here. And once again, once I start this multiplication process here, the denominators are going to cancel. So I'm going to be 6 multiplied by x plus 2 after canceling that x in the first situation there, in the first term, plus, this time the x plus 2 is going to cancel, so I'm going to be left with 6x. And then on the right-hand side, the 6 will cancel, and I'll be left with 5x times x plus 2. And again, that restriction stays there. And so now it's a polynomial, so I'm just going to multiply it out. So 6x plus 12 plus 6x is equal to, here we go, 5x squared plus 10x, where x cannot equal 0 or negative 2. So a quadratic popped out of that. So now I'm going to move everything over to the right-hand side because I like it when the quadratics are equal to 0, but I also like it when the quadratic term, the x squared term, is positive. It's just easier to work with, right? So on the left-hand side, I've got 6x and 6x, that's 12x. And when I bring it over to the right-hand side, by subtracting it, I'm going to get negative 2x. 10x minus 12 will be negative 2. And then I'm going to subtract that 12 from both sides, get negative 12. And again, with the understanding that x cannot be 0 or negative 2. Okay, so now I got to factor that. And yeah, that doesn't look like that's going to be factorable here. Now, when I run into a situation like this, I don't typically spend a whole lot of time fighting with it. If I can't see how to factor it, I'm going to jump right into the quadratic formula. So the quadratic formula here is going to tell me that x is going to be equal to the negative of the b value plus or minus the b value squared minus 4 times the a value times the c value. Whoops. All over 2 times the a value. So that's going to give me, what is that? It's going to be 2 plus or minus the square root of, that's going to be 2 squared plus 20 times 12 is 240. That's going to be 244 all over 10. Oh boy, 244. 244. Wow, 244 does not have a nice square root. I can take out a 4. I can write that as 4 times 61. 61 is prime, so that's the best I can do here. So that's going to be 2 plus or minus the square root of 4 is 2, so I can take that out front. And then I've got a common factor of 2 to the 2 here, the 2 here, and the 10. So that's going to get me 1 plus or minus root 61 over 5. Ooh, yikes. Now, I stopped writing the x can't equal 0 or 2, or negative 2, I should say. X can't equal 0 or negative 2. X can't equal 0 or negative 2. X can't equal 0 or negative 2. Well, it turns out it doesn't equal either one of those. X has got to equal this kind of an ugly looking number there. But that's okay. That is the answer, actually. That turns out to be an okay solution. So don't be too thrown off here if you're working through a problem and you find, oh boy, I can't factor it. You do have a tool. You've got the quadratic formula. You can keep working forward on that one. Okay, so for this next question, we're going to find the value of x satisfying the rational equation, and we've got 3 over 3x minus 2 is equal to 6 over 5x. The value of x that satisfies this is, okay, well, first of all, it doesn't look like there's no factoring that can be done there, but I do have fraction equal to fraction, so I've got a proportion here, so I can apply that cross multiplication, so it will be 3 times 5x will equal 3x minus 2 multiplied by 6. Okay, and under the stipulation here, remember, we got to identify the non-permissibles. X cannot equal, so now from the left-hand side there, it'll be positive 2/3. And on the right-hand side, it's just going to be that 0 there. So on the left-hand side, remember, you bring over the 2, divide by 3. And on the right-hand side, with the 5x equal to 0, the only way that could happen is if x is equal to 0. So those are my restrictions here. So now, multiply that out. So 3 times 5x is 15x, and then I'm going to distribute the 6 through. 18x minus 12. X cannot equal 2/3 or 0. Actually, you know what I'm going to do? I'm going to bring the 12 over, and I'm going to bring the 15 over so that the numbers work out a little bit nicer. I avoid the negative that way, which is fine. I don't really want to work with the negative. And then if I divide both sides by 3 here, I get that 4 is equal to x. And remember, that isn't either one of those restrictions. So there we go. X is equal to 4. That's the answer we're looking for. Okay, and finally it says, when the rational expression 2x over x plus 1 minus 5 over x minus 1 equals x squared minus 17 over x squared minus 1 is simplified, then we get x equals a, x equals b as a result. The values of a and b are, okay, so we know that we're going to get 2 solutions, which is kind of nice here. So first of all, I'm going to do some factoring here. And I'm going to get 2x over x plus 1 minus 5 over x minus 1. There's really nothing I can do there here. Now, notice on the right-hand side here, I've got this x squared minus 17. I am tempted to want to factor that as a difference of squares, but 17 isn't a perfect square. So I'm going to leave it like that and hope for the best that it goes away here. But x squared minus 1 in the denominator, that is a perfect square. Sorry, not a perfect square, difference of squares. Yikes, difference of squares. So now, the lowest common denominator here, now I see an x plus 1 in 2 terms. I see an x minus 1. So my lowest common denominator is going to be just that product, x minus 1, x plus 1, or whatever, with the understanding that x cannot be equal to either plus or minus 1, because that'll make a denominator or 2. Actually, each one of those will make 2 denominators equal to 0, and I don't want that. So in my next step, when I multiply that through, on the far left term here, the x plus 1 will cancel. I'll be left with 2x times x minus 1. Then the x minus 1s will cancel, and I'll be left with 5 multiplied by x plus 1. And then on the right-hand side, and this is actually quite nice, the entire denominator cancels, and I'm left with x squared minus 17. And that's okay. I'm hoping that that'll kind of fix itself up here in just a moment. So now on the left-hand side, I multiply out or distribute out those 2 terms. X can't equal plus or minus 1. We'll bring everything over. So x squared, what do we got here? We got minus 5x. On the left-hand side, we've got minus 2 minus 5, so negative 7. And then I'm going to bring the 17 over. Oh, nope, you know what? I just noticed in my work here, I made a little error. Okay, here's another spot. Here's another spot where it's just a little thing, but these little things kind of mount up here. If you haven't noticed yet, maybe you want to pause the video, you want to look at my work and see if you can catch the mistake here. Okay, the mistake is right here. I did not distribute that x through. Okay, that x needs to go to both terms. I missed distributing the x to the negative 1 as well here. So that actually changes a little bit of what we get here. What's going to happen here is I'm going to get negative 2x minus 5x, or negative 7x. And then when I bring that over to the other side, I add it, I'm going to get plus 12 here. Now, based on some of our previous questions, or at least one of our previous questions, you might be a little tentative here thinking, oh, I hope this factors. And in this case, it actually does. It's x minus 3, x minus 4. So x is going to equal 3 or 4. It doesn't equal plus or minus 1. That's not a problem. So those are my 2 solutions. My answers here, respectively, are 3 and 4 or 4 and 3. Order doesn't really matter here.